Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
Hi, Chris. How are you?
Good. How you doing?
Very nice to meet you.
Nice to meet you as well.
I have enjoyed your content online for a few years now, so it's really solid stuff. And I thought, what better day than to bring Chris in right after everybody fucked up their diet?
Yeah, that's right. Well, I just want to tell a public health message that you did not get sleepy because the turkey was high in tryptophan. So
Yeah, that's
we'll leave
weird.
it at that.
Isn't that a weird one? That's a weird myth that's persisted for a long time.
I mean, the weirdest thing is the origins of it. Apparently, it came from researchers journalists in the 80s who were trying to come up with a reason to explain why everyone was tired on after Thanksgiving meal. And they just looked as far as, turkey has tryptophan, which is an amino acid that is the precursor to melatonin, which is you could call it a sleeping chemical. So it makes you get tired at night. That must be why. But it turns out that turkey's not that high in tryptophan. Like even whey protein is higher in tryptophan than turkey is. And then B, tryptophan doesn't make you tired. I dare anyone to go out and have just a slice of turkey for breakfast and see if it knocks you out.
It's overeating. It's like so obvious.
Yeah.
I mean, people are eating tons of stuffing, tons of sides. They're eating so much food. Yeah. You're gorging. It's a gorging day.
Yeah, for sure.
Yeah, I mean, it's not good.
Yeah. And if you look at like a lion in the wild, one thing that you'll notice is that they are on the prowl when they are hungry. They're alert, their bodies revved up, and then they have a feast and they just fall asleep. And the reason is that you even see this in physiology. They call the parasympathetic nervous system the rest and digest system. And that's because we are biologically wired to be alert when we need to work to get our food. And then we're wired to, eat that food, feel like we've gotten our fill, we've done what we need to do, and we can rest and take a sleep.
Yeah, it's normal. I mean, there's a great video of these lionesses, these female lions after they've hunted and killed and ate all this food, and they're just lying there like this with these enormous bellies, just like, just like your uncle on the couch watching football, just,
Yeah, I think one thing that I think we should talk about today is I've been in nutrition research for 21 years, and I think the crowning thesis of my work so far is that we really want to be thinking about mitochondrial function at the root of all health and disease. And so I think an interesting way to see sleep is it's like, why do we have to sleep 8 hours a night? And I think with dreaming, there's obviously other things going on there, but deep sleep, one of the primary things that's happening is you need to give your mitochondria a rest, because your mitochondria are what produce all the energy that you need for producing everything in your body, for maintaining it, for repairing it, and for distributing it properly, and for keeping it going across the lifespan. And so your mitochondria are going to essentially take a nap, take a rest. They don't go off because you die, but they really turn down the volume of the work they're doing. But then you take your metabolic rate way lower than that. And so you can build up the reserves of energy that you had used up the day before. And so it's, that can explain a lot of recent findings that are coming out as well, because there was that recent study where they looked at sleep deprivation with creatine supplementation. And so they randomized people to either drink a placebo drink or drink 20 grams of creatine through the night. And they kept them awake all night, and they had them do brain puzzle quizzes. And when the subjects were getting the 20 grams of creatine, they did way better on the brain puzzles, but they also complained about being tired a lot less. And so the conclusion is creatine is somehow acutely preventing your brain from suffering during sleep deprivation. And the rationale there is, mitochondria are the powerhouse of the cell, or the power plant that's producing the energy. Creatine is like the power grid, and it distributes that energy throughout the cell. And so if the purpose of sleep is to restore the energy that you used up, but then you intervene by putting creatine in there, now you can keep that energy going and you can go more hours before you need to get rest and restore that energy because you've increased your capacity to distribute it.
That makes sense. That is an interesting thing because it's fairly recent that people have talked about this, right?
Yeah.
I mean, it used to be people only thought of creatine as being a muscle thing to help you recover and help you build larger muscles. But then over the last, I would say, year or two, I started hearing talking about cognitive function, and maybe even more than a couple of years, but about how it improves cognitive function. The sleep thing, though, is very recent, right?
Yeah, the sleep thing was in the last year.
Okay.
There is some literature on traumatic brain injury where 20 grams of creatine for 6 months doubles the rate of healing.
Whoa. That's incredible.
But it's, the field is in its infancy, but I think that I actually almost a decade ago did a podcast on just creatine. I called it More Than a Performance Enhancer because if you just look at where it's distributed in the body, almost every cell and every tissue has the creatine system. And so it really is this. And if you look at the literature, they'll say, well, it's more important in certain cells. Like it's really important in your muscles because your muscles have this very polarized, sometimes they're at rest, sometimes their energy demand is going through the roof. And it's really important in like long cells. So for example, your retina is part of your central nervous system. And it's this really long cell that's coming from the brain into the eye. And creatine helps move energy back and forth. But if you just look at where, instead of where is it most important, you just like, where is it? It's like almost every cell in your body has creatine. And it's helping distribute the energy that the mitochondria make throughout your whole body. And that includes pumping stomach acid. It includes sperm swimming up the vaginal canal. And so if you just look at where it is, you would think that creatine would help a lot more than muscles. And it just turns out that all you need to do is start studying it to start seeing those effects.
Is there any studies on creatine and the improvement of eyesight?
I'm not sure. Not that I know of.
Because that kind of makes sense,
yeah,
right?
I mean, it makes complete sense. Like you would, when it comes down to it, your ability to produce energy is maintaining and repairing everything in your body. So you would expect to see anything that does improve your energy metabolism improve literally everything. So it'd be kind of shocking if you had no effect on that. But I'm not sure if there are good trials done on that. I haven't seen them.
Speaking of improving eyesight, I started doing red light about a year and a half, 2 years ago, got a red light bed, and completely stopped whatever macular degeneration I was going through and reversed some of it. So I don't have perfect vision, but my vision's better. Like it's definitely better. And it's not just through the red light. It's also, it's got to be some of the supplements that I'm taking. One of them, I take a supplement from Pure Encapsulations. No affiliations with them. I just buy it. It's called Macular Support. And let's see what's got in there. It's got lutein and a few other supplements that have been known to.
Yeah, that'll do it.
Is that it?
Well, yeah. I mean, so with the red light, it is very interesting. Whenever you think of red light, you want to think of your mitochondria because the main thing that we know about red, near infrared, and far infrared that they're doing is they're actually going straight into the mitochondrial engines that produce the energy and helping them produce more. And they're also ordering the water structure inside the mitochondria to make those engines produce energy more easily. And there was a study a few months ago that it was just like a one-day study, but it showed that blasting people in the chest with red light improved their eyesight when it was measured the next day. And they covered their eyes to make sure that the red light didn't go into the eye. And so the conclusion is, it's not a clinical study, right? And it's not like a 1 year, how does it, does it really improve your eyesight over 1 year? We don't know. But it shows proof of principle that red light is doing something systemically that does not have to go to your eye that does improve your vision. And to me, that makes sense because your vision is going to be improved by anything that acts directly in your eye to improve energy production. But you've got coordinated energy metabolism going on through your whole body. Like your liver is doing tons of stuff to try to make your eyes healthy and make your brain healthy and so on. So it makes a lot of sense. But so I don't doubt at all that the bed part of that. But the lutein and zeaxanthin are well known to accumulate in the macula, where they have a very specific role in protecting against macular degeneration. And actually, the best source of those is egg yolks from chickens that are fed anything that has them, but marigolds are super high in them. So if they feed the chickens marigolds, they get super high levels. And the egg yolk has fat that helps them get absorbed. So in terms of, I mean, this is you could take this with some eggs, but
should feed my chickens marigolds.
Yeah, if you have
chickens.
If you have chickens, and if you're spending your money on a lutein zeaxanthin supplement, you might be able to get maybe the marigolds are cheaper. So.
Maybe I'll just double it up.
Yeah.
So this is all the ingredients. Does this stuff make sense? Is something that would help support eyesight?
It does. I mean, the vitamin A is going to that's going to depend on your genetics in terms of how good are you at converting beta carotene into the form of vitamin A that we need, which is most abundant in liver and egg yolks.
It's dependent on genetics.
So you need beta carotene is this big, and if you chop it in half, you get vitamin A. And so you have an enzyme in your digestive system that does that, but that enzyme is dependent on a lot of things going right. So you need to have good zinc status, good iron status, good thyroid status, and all kinds of stuff like that. And actually, seed oils decrease the conversion. So if you take that with canola oil, you're going to get less vitamin A out of it than if you take it with eggs and butter. And then vitamin A activation is also dependent on mitochondrial function too. So but it makes sense. Vitamin A is great for your eye. Vitamin C is a great antioxidant. N-acetylcysteine, great antioxidant. The glutathione, the Cetria stuff, I'm kind of, I think it's a little bit of a overhyped in terms of some, another type of glutathione I think would have worked fine.
What's the best glutathione?
Well,
is it liposomal?
The best glutathione is the glutathione that you make yourself from protein that you eat. But if you're going to supplement with glutathione, if you're talking about bang for the buck, I just think straight up glutathione is good. And there are studies suggesting that there's marginal absorption benefits for certain special types. But then they charge 3 times as much for that type. And it's like, well, am I getting 3 times more glutathione out of it? Not really. So, some people swear by liposomal glutathione. And if you swear by it and if it does its thing for you, great.
Do you think it's 10% better?
I think the jury is out on whether there might be 10, 20% better value for those things. So if I'm going to take glutathione, I'm just going to take glutathione.
Got it.
Yeah.
Okay. Is this what you're saying about producing your own glutathione? That's the same thing as like vitamin D, right? It's way better when your body produces it. If it does.
I mean, I don't think there's anything wrong with getting vitamin D from food, but the thing is you do need sunlight, right? So you at least need to get 30 minutes of sunshine in the morning, which is not going to give you vitamin D. And then you need to get like 10 or 15 minutes of unprotected sunshine in the afternoon you get vitamin D from that, but you get other benefits from it as well. So I wouldn't say that it's necessarily better to get the vitamin D from the sun than from a vitamin D supplement or from eating fish or from eating cod liver oil. But you don't want to say, well, I don't need to go out in the sun. I'm just going to take vitamin D. Then you're not going to get the benefits of the sun because the sun gives you other benefits.
Got it.
Yeah.
Is there anything that you can do, say if you live in Seattle and you're in the winter, it's just raining constantly. Is there a tanning bed that gives you some of that? Yeah,
I do think that there is some risk of tanning beds. I'm not 100% comfortable. When I lived in New York, I would try to spend 40 minutes in the afternoon sunshine for 3/4 of the year. And during the winter, the UV index just wasn't high enough. And I get eczema in the winter because I'm not getting enough sun. And so I would use a tanning bed not to get tan, but I'd use like 2-3 minutes at a time just because it just had a systemic effect in preventing the eczema that I would get in the winter. I think you have to be careful with it because there is some concern that people are just, if they're tanning to tan, they're going to wind up with too much damage to their skin. But what I would do is for morning sunlight, I think you can get like a Lux Meter app and just some people they think that there's no sun outside, but actually it's like 100 times or 1,000 times brighter than indoors and their eyes are adjusting. And so it's like cloudy or overcast, but there's still a lot of value in going outside. So I would say if you use a Lux Meter and it's like under 10,000, you could get a light therapy light at home to use to just like turn it on and not look straight into it, but kind of have it going into your eyes. And then for vitamin D, you could do like tanning bed, but just try to really keep it minimal, like go in for 2 or 3 minutes, not like you're trying to tan. You're just...
What I was getting at, is there a different kind of tanning bed that's maybe...
Oh, there
imitates...
are. Yeah, so there are different ratios of wavelengths, and the ones that have more UVB are the ones that are going to give you more vitamin D. So if you're just going to a tanning bed place, you probably the staff there tell them that you want like mixed wavelength that gives you a mix of like surface tan and deep tan. Okay. I think that's how because they don't know the vitamin D science. So I think that's how you have to get the bed that gives you more vitamin D.
You have to tell them I want a mix of surface and deep. That's funny. Speaking of red light and speaking of therapy that helps your mitochondria, what is your thoughts on methylene blue? Methylene blue seems to be a very controversial supplement. Some people think it's amazing and it's a panacea for all that ails you, and other people are like, what are we doing here? Why are you putting dye in your body? Your piss is coming out blue. This is weird. What school are you in?
Methylene blue is something that could do wonders for your mitochondria if you need it and could really hurt you if you don't. And I think that there are certainly a lot of people raving about it on the internet, and it's because it's a mix of things. So there are people that are treating themselves for a problem in their mitochondria that they don't know that they have, and then they get an outsized voice because they're the ones raving about how much it helped them. And so there's like selection. You know, if people didn't get a benefit or if they just felt a little worse, they don't go raving about it on the internet as much. Yeah. So that's part of it. There is also a part of it is that when you get up to a dose of around 10 milligrams or so per day, for perspective, in clinical trials of Alzheimer's are using 200 milligrams, but you can buy like a 0.5 milligram on Amazon. So a lot of people are using like 0.5 milligrams. But once you get up to 10 milligrams or so, you're getting some degree of pharmacological antidepressant effect because it's an monoamine oxidase inhibitor. And so I do think that there are some people they're like, oh, I feel so much better. And it's like, yeah, bro, you're taking an antidepressant. So that's part of it. But if you look at what it actually does, it is a very non-specific rewirer of how your mitochondria produce energy. And if you can think of it like, let's say there's a main road in the city and it's the best road and that's why everyone's on it, but it's blocked, and then they set up detours, people are good. They're going to help the traffic because that road is blocked. You actually can't get through there. And so the side roads that would take you somewhere are actually better because they're not blocked, right? So in the context where you need the detours help you. But if the main road was not blocked and they start putting up detour signs and people start going out in the side roads, they're not going to get to their destination faster. They're just getting tricked by the mess, the chaos that was created by people putting up detour signs that they didn't need. So methylene blue is something that goes into your mitochondria and sets up detour signs all over the place. And
how does it do that?
So all right. So what your mitochondria do to produce energy is they extract, you have a molecule like carbohydrate or an amino acid from the protein that you ate, or fatty acid from the butter you were eating. You got to break that apart. You got to take out the energy, and you got to synthesize ATP with it. The ATP is the general energy currency of the cell. So mitochondria produce usable energy from food in the form of ATP. When they do that, they have a bunch of different pathways through which electrons flow. And methylene blue is able to grab those electrons and put them somewhere else. So they call it a redox cycler. So it's taking an electron here, it's shuttling it over there, it's taking an electron here, it's shuttling over there. And so if you have this let's say the normal way for your mitochondria to produce energy has a main road where the electrons just flow straight through, methylene blue is coming in and it's just taking that electron over here, it's throwing it in over there, and so on. So if you've got a road that goes like this and you got a blockage right here, and methylene blue is just taking something out there and it's putting it over there, you actually wind up getting better energy with it. But if you don't have a blockage, you're just creating random chaos in the mitochondria. And in animal experiments, what they've done is they've said, okay, let's give these animals inhibitors of their mitochondria at specific locations and see what methylene blue does. And if you don't have any inhibitors, and if the animal is genetically healthy, then you add methylene blue, they get less ATP. So the mitochondria is less effective at converting food to usable energy. But if they do have an inhibitor, their ATP production goes down, you add methylene blue, it goes back up, right? So if there's a blockage to get around, methylene blue helps. So I think what's important if you really want to make sure that people are using methylene blue right is to actually do mitochondrial testing that will tell you whether those specific blockages are there. I ran a biochemical optimization program a while back, and one of the clients that I had in there, he tried methylene blue and he only got up to a 0.5 milligram or 1 milligram, and his mood was worse, his fatigue was worse, he had more anxiety, a bunch of problems that, the dose was too low to say it was doing a pharmacological messing with his neurotransmitters. And so I think it was just making his mitochondrial function worse. And so the mitochondrial testing that we did on him showed that, he was not a candidate for methylene blue. And he actually had, some really weird, his mitochondria were best at using a specific amino acid, cysteine, and for energy. Kind of weird and idiosyncratic. And in his case, it was interesting because he had actually gravitated to a steak-only carnivore diet. And he didn't feel like it fixed him, but he felt like it, took the edge off. Like he was 50% better on the steak-only carnivore diet. And
50%'s a lot.
Well, it's a lot, right? But he wanted the other 50%. That's why he was coming to me. Yeah. So what was, figuring this out didn't get him to 100%, but it got him to get days with 75%. Because he could use strategic cysteine supplementation to mimic the benefit he was getting from the steak, but he would be able to, be still in the fasting state because his workouts were better in the fasting state and things like that. So figuring that out allowed him to, get from 50% to 75%. But the methylene blue was putting him down at 5% instead of 50.
Can I ask how old he was?
He wasn't that old. He was in maybe 40. I forget exactly, but 40, give or take 5 years.
And is that an age-dependent thing, like mitochondrial dysfunction? Is it more common in older people?
For sure. So I would argue that mitochondrial dysfunction and aging are the same thing. And there's a bunch of theories of aging, but if you take them all, you can always ask the question, why? There's the information theory of aging, why is the information not being carried out correctly? Or the oxidative stress theory of aging, why are you making more oxidative stress? And I actually think it's way more simple than anyone is thinking about it. It's mitochondrial energy production is producing everything in your body, it's repairing it, it's maintaining it, and it's putting it where it belongs. That means that mitochondria produce the energy that they need to produce everything in the mitochondria, right? And so if you have a little gap in your energy production, let's say you get, I think one way to think of aging is, well, I've suffered through so many cumulative insults. Like I got sick so many times, I got injured so many times, I had days where I didn't eat optimal nutrition so many times. And I think what all those things are doing is that period of overtraining that you did, your mitochondria were forced to help you give you the energy for, that the extra set of squats that you did, and they had a little bit left over for themselves, and they got, 0.5% worse at producing energy. And so that sets up a vicious cycle, because now that they could not repair themselves as well, now they get a little bit worse. And what you see in the literature is that as people age, starting around age 18 through age 70 to 80, you're losing your mitochondrial function at an average rate of 1% per year. So by the time you're 70, you have half the energy that you started out with at baseline. And that I think what explains that is just the vicious cycle of the mitochondria they lost 0.25% here or 0.25% there, and they just started repairing themselves less effectively because they're the engines fueling everything, including that. And so, but the good news is that age only explains 25% of mitochondrial function. So it's the average that's going down at 1% per year. The average person is producing half the energy at age 70 than they were at age 18. But the spread around that is huge. And with that, to me, the way that I spin that means that 75% of this is under your control. You're gonna go in a downward trend, but you're in control of whether you're way undershooting that trend or you're way overshooting it. What you want to do is make your mitochondrial function as good as it can be at any given age, so that that downward trend will it'll be a lot slower, and you can get to age 70 and you're not docked 50%, you're just docked 10%. And I think that's what's happening when you see some of these 70-year-olds who are more fit than a lot of 25-year-olds,
Yeah, interesting. So what are the primary factors in regards to being able to maintain your function?
Well, I think that everyone has idiosyncratic things, and I think mitochondrial testing is very important. But if I were to pick 5 things that just everyone should be doing for their mitochondria, a lot of it does look like health advice you might get somewhere else, but it actually is the best stuff, right? So we mentioned creatine, and I think creatine is really important because it's not in the mitochondria so much as it carries forth the mitochondrial energy of the rest of the cell, but that also feeds back in the repair functions for the mitochondria. And so I think optimizing your creatine status is super important. And I think that everyone who's not eating 1 or 2 pounds of meat per day should probably be taking creatine. And you can think of it as if you're eating red meat and you're eating it rare, you can err on the side of 1 pound. And if you're eating, and I would include as red meat salmon, which is like a reddish fish and is actually quite high in creatine. If you're eating white meat, white fish, and you're eating it well done, you want to err on the side of 2 pounds because they don't have as much creatine, then you cook the creatine out of them and you wind up with much lower dose.
We should probably say salmon. You're talking about wild salmon versus farm salmon, which has a dyed pink skin.
Well, it's not the red color. I think it's coincidence that it's. I think the red color is coincidence. It's just a helpful way to think about it. But it probably is the case. At least like every Atlantic farm salmon that I've seen you can tell that it's if you look up it in a database, it's way higher in fat. But you can tell by looking at it that it just doesn't have that lean look that wild salmon has. So I think creatine is a function of the lean tissue mass, and it might be the case that wild salmon are doing a lot more swimming, like maybe the wild environment is encouraging them to use their muscles in a way that increases their creatine synthesis. That wouldn't surprise me. I have tried to steelman the case of, could there be a vegan diet that would make you not need to supplement with creatine? And the steelman that I've got for you is you'd have to be eating 0.5 kilogram of tofu and 0.5 kilogram of quinoa per day. And that's not typically what. And that might rip a hole in your digestive system, but that's not
hurt my stomach just saying.
So I think that most vegans should probably just supplement with creatine. Call it a day there. So that's creatine. we mentioned sunlight. So sunlight is, when you wake up in the morning, I said before that your mitochondria have not gone to sleep literally, but they've really slowed down. It's like they're on a nap. And there's a transition when you wake up where the mitochondria have to say, oh, you've woken up. Now I need to wake up and I need to start producing more energy. And sunlight going into your eyes, being translated into your brain, is the signal that actually tells your brain to organize that. And so what happens as a result of that is that signaling helps your mitochondria adapt and start producing everything, and it actually helps them adjust. And if you don't have the morning sunlight, you're going to have your mornings full of suboptimal energy metabolism that is initiating that vicious cycle of aging. That's what I believe. And then it's also the case that the red and infrared light from the sun is very beneficial to the mitochondria. The best time to get that would be in the morning. When you go out in the afternoon, you've got to deal with, like, can I get 2 hours of this without getting burned? But if you go out in the morning, you can stay out there for 1 or 2 hours and you can get a lot of red and infrared light without worrying about burning wavelengths. And then I think the beds and other devices at home are great. And where you want to start thinking about that is, I'm getting benefit from red and near infrared light, but I'm getting more. I know that I could get more benefit if I got more of it than I'm able to get through sunlight. So start getting those wavelengths with sunlight as your base, and then do whatever you want on top of that with whatever seems to be working well for you. Then nutrition would be number 3, and every nutrient is needed for everything in your body, but your mitochondria are using all kinds of nutrients. And there's this idea that floats around in society that nutritional deficiencies are a thing of the past. But if you just look at surveys, 93% of Americans are getting less than they need of at least one nutrient. 30% have verifiable blood markers of at least one nutritional deficiency, and 6% have blood markers verifying more than one nutrient deficiency. And I think those are all underestimates, because when you're just looking at the official stats on, like, how much of each nutrient should you eat, there are a lot of people that have needs for way more, right? So I think those stats are grossly underestimating how many people need to get better nutrition. So I think everybody should be getting better nutrition. And to kind of high level what that looks like, I think some good rules of, there's lots of ways to skin a cat, but some good rules of thumb are, different people will do better with more plants or more animals, but when you do eat animals, you should be eating them nose to tail. So at least try to work in liver, at least try to work in bone broth, or something like that. The closer to nose to tail you can eat your animals, the better. Do try to diversify across proteins, because there's just different vitamin and mineral profiles in different types of protein. Like, if you can eat shellfish, eat some shellfish. If you can eat fish, eat some fish. You can eat dairy, eat some dairy. And the more you diversify across those proteins, the better. Most people don't eat enough protein. Good rule of thumb would be at least 1/3 of your plate should be protein. But if you're talking like eggs and dairy products, you've got to double that, because the amount of space they occupy per unit of protein that they're giving you is 1/3 of your plate as eggs is not going to give you enough protein. And then I think try to eat as broadly as you can from different types of carbohydrates. If you have to leave out something, leave out grains. Try to eat whole, unprocessed foods, and try to eat 80% of your foods cooked at home or prepped at home or whatever, instead of eating out. And make sure your digestion is in good order. And those are kind of the broad basis of nutrition.
Yeah.
Exercise is a very interesting one. So exercise is incredibly important to the signaling that produce mitochondria. But why is that? It's because you need mitochondria to produce energy for the exercise that you're doing. So I think a lot of people are too reductionist when they look at what type of exercise should you do for your mitochondria. If you try to do a study that says like, I'm trying to get more mitochondria in my skeletal muscle, what exercise going to do it? You're going to see endurance exercise outperforming other things. And that's because endurance activity requires more mitochondrial function in the muscle. If you're doing like hypertrophy or strength training and you're doing short sets, your muscle's burning a lot of glycogen. It's less dependent on its mitochondria, so you're not going to see the mitochondrial function there. But that doesn't mean you're not improving mitochondrial function, because now all that really means is the liver is stepping up to assist the muscle. Like if you're doing sprinting, your muscle's burning through tons of carbohydrates, making a lot of lactate. If that lactate's not being metabolized in the skeletal muscle, it's going to the liver to get converted back to glucose. So your liver, now you're training your liver's mitochondria when you're doing strength training, you're doing hypertrophy. So I think the right way to look at it is just you should be exercising all the things that are functions that you need to keep. And that means endurance, it means strength, it means mobility, it means agility, it means balance, it means proprioception, it means being able to respond to your environment. I think to some degree, like just playing a sport that has other people in it is important, because if someone's throwing a frisbee and you need to react to that, you're training mitochondria in your brain that are able to energize the systems that provide your reaction time. And I think cognitive, exercise for your brain is things like working on your memory and on your creative synthesis and all those different aspects. And I do think that a lot of people are thinking about this when they're 25. They're like, well, I don't care if I can memorize a string of 25 numbers. But you're going to care if you can't remember anything when you're 75, So I think that we really need a broad thought about this. But by the way, do you know what athletes live the longest from the pros?
Let me guess. Baseball?
So it's actually gymnasts and pole vaulters have 8 years on the general population. And if you look at, there's a study that came out earlier this year, and it tallied up all of the pro sports players from all of the countries who had the dates of their death published and who were notable enough to have had an article published about them. And so they had many hundreds. I forgot the exact sample size, but they were able to statistically adjust the mortality rate to the general population from which the athlete came. So if it was a Greek athlete, they were adjusted to the mortality rate of Greece when they died, what you would expect after adjusting for location and age and so on. And in the male athletes, you had gymnasts and pole vaulters with 8 years on the population. And you've got cyclists and of course you've got sumo wrestlers are 10 years below. And you have a lot of sports that have high injury rates that are, especially a lot of stuff that has impacts to the hands, martial arts and things like that, where probably the sport itself and its impact on training your body's energy systems is positive, but just the injury rate is taking you out. So you're kind of like not, you're kind of in the middle. You're very close to the general population. Cyclists only have 2 years on the general population. And so what I thought was interesting, I think a few things are interesting about that. So first of all, there's a lot of people in the longevity space are taking most of their information about how they should train for longevity from people who specialize in cycling.
Really?
And so, I'm not going to name names, but there's, there's the people out there who are, that's where it's coming from. And it makes a lot of sense that cycling is, it's good for cardiorespiratory fitness. There's a lot of data that having good cardiorespiratory fitness is a key factor for longevity. But when you look at a study where gymnasts and pole vaulters have 6 extra years on the cyclists, and the cyclists only have 2 extra years on the general population, I'm like, what, it's not all about the cardiorespiratory fitness. And so when I think about it's an observational study. You can't prove cause and effect, but it just does make you think. And the way that I think about that is a few things. So first of all, the commonalities between gymnasts and pole vaulters, it's definitely not height, because gymnasts tend to be short and pole vaulters are tall. And so the height cancels out. Definitely they're fit. They do both have, it is interesting that they have, cyclists have a good lower body and gymnasts and pole vaulters have a good upper body. So I do think that's interesting that it does make you wonder if you could skip leg day. But I don't advocate skipping leg day. But to me, like what I think is actually going on here is I think that functionality of movement throughout the whole body to facilitate the kind of skills that they have is training. It's training it things that are getting left out when you just make sure that your heart and lungs are able to support your running or your cycling. And I think that some of those are probably related. I don't know what they're not dying of. So presumably they're getting less heart disease or getting less cancer and they're getting less neurological disease because that's what people are dying of, right? Like in the average, if you get far enough for someone to analyze why you died, they're like diabetes and hip fractures and things like that are hitting younger people. But in general, if people are dying because they got old, they're dying of heart disease first, cancer second, and if they outlive those two things, you get this diverse spread of things that people die of, and diverse neurological diseases becomes pretty heavy. So I think cardiorespiratory fitness is probably the biggest thing in preventing heart disease. But cancer becomes very interesting because there was a study in rodents that showed that stretching prevents tumor growth. And I thought this was wild. I first heard about this on one of Huberman's shows. And so I looked up the study and I was like, this is wild because I happen to know some other things about immune function. So one thing is that when in T cells, which are important both to prevent infections and are also important because they attack you during autoimmunity, and they're also important because they kill cancer. For T cells to be activated, what they do is they don't have enough energy themselves, so they push off the local environment, and that pushing off creates motor proteins inside that generate the energy to activate the T cell. And what cancers do is they modify their extracellular environment to compromise that because it's harder for the T cell to push off of it. Now, I know another thing from Crohn's research, which is that the best way to cure Crohn's disease, besides some of the drugs that they're on, is a liquid diet. And the recent research on how the liquid diet works is that it removes the pressure in the intestine that is pushing out and is causing inflammation to activate and attack the body, right? So I'm synthesizing these three things and I'm like, this makes a lot of sense that the relative proportions and how stretched out and like what is the quality of your joint tissue and things like that probably has a lot of severely underappreciated causation in terms of cancer and autoimmune disease. So I think it would be very interesting to see if actual like functional mechanical activity, like if you optimize for functional mechanical activity such that you can swing around from acrobat from a trapeze and flip around in the air and swing on rings and push yourself up and stuff like that, does that pay forward into better immune function because your body is more properly structured? I can't prove that, but I think it's very interesting to think about for those two exercises. And then it is very interesting to me that gymnasts and pole vaulters both spend a lot of time upside down, and they don't stay upside down for very long, but they repeatedly are upside down quite a bit, right? And so this is all just hypothesizing interesting ideas, right? So one interesting idea is that a vibration plate is the sedentary man's gymnastics, and that, flipping upside down is better at circulating body fluids than walking. And like a vibration plate is better than walking, but actually spending time in the upside down state and flipping around is actually very good for circulating the fluids in your body. I can't prove any of this, but it's all very interesting to think about. But what I kind of conclude from this is you don't want to get sucked into just optimizing VO2 max or something like that. You really want to, the lesson from the gymnasts is like, what are all the things that a gymnast can do that I can't do? And I should be able to approximate them in the best way that I can. And I take that a little bit more literally. So I actually do I am trying to convert all my workouts into like, what's the gymnastic version of this?
And you think it's because of flipping? You don't
Well,
think they're both involving coordination, explosive movement.
Right. And I think
skills.
I think that yes. So I think the skill training is big for spill off into neurological disease but I'm just trying to connect them to the three things. So I'm not sure exactly what they have lower rates of death from. We need more studies to see that. But the body mechanics, I think, is a very interesting possible explanation of why they'd have lower rates of cancer. And what you just said, I think, is a great explanation of why they would have lower rates of neurological disease. And I think it's kind of like, if you look at, I think another thing that people mistake in the longevity space is they spend too much time thinking about reverse engineering 100 backwards. What do I want to not have lost by that time, and not enough time just being in peak function. Because if you look at bone mass, for example, bone mass goes up until you're in your mid-20s, maybe 25 to 30. There's a little bit difference with men and women, but then it just goes down after that. And if you want to have good bone mass when you're 75, the most important asset you could possibly have is to have really good peak bone mass when you're 25, right? So I really think that it's just like I said before, you might not think memorizing a string of 25 numbers is important at any age, but if you're going to have really awesome peak memory, that gives you a lot of room to decline later on. Whereas if you're trying to reverse engineer what you don't want to be able to not remember when you're 75, I think you're just setting the bar way too low, right? So if you're 20, you should be thinking about what are all the sports I can't do? And not, I'm not saying there's anything wrong with picking a sport, but I do think it would be good for everyone when they're young enough to do so, to just try a different sport once a year. And maybe they don't love it, they don't fall in love with it, but maybe they learn something like, oh, I didn't realize I couldn't do that. So for example, I did last year, I did a little bit of BJJ and I did a little bit of boxing. And I was like, oh, damn, my feet don't move like they used to in boxing. And in BJJ, I was getting a little dizzy doing forward and backward rolls. And I was like, I don't spend enough. This is before I started thinking about the gymnast being upside down. I was like, I don't spend enough time being upside down. So I was like, so I bought some mats. And then now I just, I do one forward and backward roll every day, no matter, I don't do BJJ right now, but I just do one forward and backward roll every day as part of my morning routine. But I've also switched, I was like, why would I overhead press when I could try to do, I can do wall push-ups now. My hope is by next year I'll be able to do handstand push-ups, but I'm working on a handstand right now, so we'll see how that goes. But I think just because you can focus on one thing, you can really miss out that my favorite workout activities this is how many people are doing all their favorite workout routine activities and forgetting that they don't have any rotation. They don't have any side bending. If you would just try a different sport and be like, oh, what did I not realize I wasn't able to do at all? And then pick that and put it in your workout. Because if you got a great programmer, then maybe your workout is perfect. But I think most of us we gravitate towards some of the exercises that we think are good. And even if you think you're mixing it up, like CrossFit managed to eliminate rotation from everything. Every sport that involves throwing a ball involves rotation, right?
Well, they do sometimes. They throw the ball sideways against a wall. There's some rotation in.
Oh, maybe they
some
worked it in.
CrossFit.
When I did CrossFit, the ball throwing we did was
Really,
wall balls, and it was like
depends.
Yeah.
I think it depends entirely on who's teaching it. But
Yeah, that
if
makes a
you're
lot of
doing
sense.
windmills,
Yep.
windmills are
Yeah, for
kind of
sure.
a form of
Yeah.
rotation. There's a lot of ab exercises they do that are rotational.
Yeah. All right. So that maybe that wasn't fair, but
Yeah.
but my point is that like a lot
A lot
of people are not doing any rotation, right?
Right.
And so I just you just want to tap into that diversity of like what functions am I not exercising, you want to exercise them.
When we're talking about skills, we're talking about the neurological system and the cognitive system synergistically in a dance. When you talk about old people, and one of the things that happens when cognitive function declines is you lose your ability to do puzzles, and one of the ways to stave that off, they believe, is like do crosswords, do a bunch of different things. Your chess, do something that's actively making your mind fire and work. Wouldn't it just make sense that a skill versus just a workout, just bench pressing and squats and stuff like that, but it's an actual skill where you're doing like Muay Thai, hitting pads, or even light sparring, that you're thinking as well as exercising, which is very different because you're consciously aware of your opponent's movement, you're calculating it, you're trying to time things. There's a whole dance going on between your body and your mind that doesn't really exist in straight workouts. So that alone, I would think, would fight off a lot of the age-related decline in physical activity or physical function.
Yeah, I think you mentioned a couple things in there. So I think it's a separate thing to have a skill and to have strategy and to have reaction time. But I think you definitely want to be hitting all those bases. So I think it's good to have a general checklist of what should you be exercising and see that it like takes strength and break it down into the different planes, and then also take skill, strategy, reaction time, agility, quickness, balance, power. And you have to find a way to, it's hard to work everything at once, but you got to find a way to maybe you cycle through switching your focus, but you find like what is, if I worked on really being able to jump rope without tripping my feet up last quarter, how am I going to take that skill and not lose it? And so for me, for example, like I really focused on jump roping when I realized how horrible I was at it when I was forced to do it in boxing. And so I very intensively tried to get good at jump roping, and now I don't want to work on it anymore, but I've just taken in like, okay, every morning I have to do 50 uninterrupted jump ropes just in the course of my warm up.
Just to kind of keep whatever skills that you've developed.
Yeah, just to make sure that like I'm not losing the basic capacity to do that coordination.
Yeah.
And if I start to, then I realize I have to work on it more.
Yeah. New things, I think, would enhance that even more maybe than things that you're very comfortable with and things you're very efficient at. Like, say, if you're an athlete in whatever sport and you say, I'm going to try jujitsu or I'm going to try martial arts. Like something completely new like that where you're working out, but you're really thinking because you've got to like really concentrate. It's not like a natural movement to throw a side kick. You have to really concentrate on picking your knee up, twisting your body and all that jazz. Like I think stuff like that would, just keep everything firing, no?
I think I think you should do a mix. Like you always want to be pushing yourself to new achievements, but then I think you want to structure things so that you don't lose the ones that you did.
Right.
Like I think a lot of us go through life just making an achievement, losing it, and we're treading water and going nowhere.
When I really got into jiu-jitsu, I stopped doing any kickboxing for a long time, and every now and then I would just hit the bag and just like, I still can do it. But then I started training Muay Thai again, and it was kind of shocking how long it took me to get like the flow back. To like, bap, 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 like where it really like comes off smooth. Everything seemed like a little labored, and it was just disheartening to like, oh, I don't really have these skills. Like I have to like reacquire them. I know how to do it. I've done it, but it's just like right now everything's a little. The pathways are filled with mud. You know what I mean? It's not clean. It's not nice and sharp. Everything is a little funky. And, but if you want to get good at jiu-jitsu, you don't have time for 2 hours of Muay Thai a day. You just don't. So it's like you got to pick your poison. You got to pick what you like and what you don't like.
Yeah. I think you have to decide what your goal is and what your metric is. Like there's no way that anyone is going to be good at like 7, going to be elite level at any 2 sports or like great at any 7, right? So I think you have to say like, do I want to be really good at Muay Thai? And that's, you don't have to do that to have healthy aging.
Right.
But there are things that you do at Muay Thai that you do have to be able to do to have healthy aging. So if you're just thinking about it from the perspective of how do I know that I'm engaging in healthy aging, I think you don't want to say like, oh, I need to be as good as I ever was at Muay Thai. You just have to say, okay, like why am I bad at some of that? And is that something that I need in general? And I think oftentimes by doing something like that, you can think about it and you can realize, oh, what I really can't do is I'm not agile anymore. Or I really can't like shift my weight quickly anymore. Or I really can't, like my reaction time is slow. Like I just keep getting hit in the head because I don't move it. If you're realizing those things, then I think you have to find some way to train those because you need those for everything. And it's easy to not challenge yourself in life and don't realize what you're losing. So you do have to challenge yourself with something you're not able to do to figure out what you're weak in.
Yeah. One of the things I wanted to bring up, you brought up earlier, you were talking about martial artists and perhaps like injuries accumulating over time, and you lose some of your function because of that. Like you mentioned hand injuries. Is that something that people need to take in consideration that maybe they don't, that maybe just physical damage, like in terms of getting hit, and physical damage perhaps from overtraining, physical damage certainly from cutting weight? A lot of these guys cut weight and they're basically on death's door 24 hours before a fight, which is, I think, completely insane. And the most avoidable damaging thing about martial arts competition. And yet it's ubiquitous. It's like almost everyone does it.
Yeah, I mean, I think there is a degree of subjectivity to it. If your idea of what a life well lived is to win an event that might have you die in the next 3 years, then how are you going to argue with that value that someone has adopted? But if you are thinking about it from the perspective of how do I stay healthy how do I live a long, healthy life, then injury prevention has to be your number one consideration, not your number 2. I think even if you were just trying to say like how can I be the strongest I could be, you would still need injury prevention to be number 1, because how many people take 3 months off from a lift that they're working on and wind up 6 months behind where they had been when they start again as a result of that injury? And where would they have been if they spent that 6 months getting stronger? And if you're going to do that every 2 or 3 years, like that's taking a huge toll off even the skill that you could develop and your maximal capacity at that. But like I was saying at the beginning, I really think that the simplest explanation for why mitochondrial function declines 1% per year and gets cut in half by age 70 is just this, like, when I was injured, my mitochondria were completely obsessed with healing from that injury, and a little bit came out of the account used to repair the home base.
That's what I was getting at. Yeah. So for someone who's had, say a martial artist who's had broken hands, broken ribs, knee surgery, shoulder surgery, a lot of these guys have gone through a bunch of stuff like that. Like, so each one of those things is taking a small toll.
Yeah.
Yeah.
For sure.
That's not something that people consider. You think, oh, you recovered from that injury, now you're 100%. But you're 100% with the tax of having recovered from that injury.
Yeah, and a lot of people aren't necessarily fully recovered from the injury either.
Oh,
and,
many aren't.
Yeah,
many aren't.
I talked to a guy once who was, he got injured in marathon running, and he thought he was recovered. And I thought he wasn't recovered, and there was some kind of metabolic stuff wrong with him because he's getting sick all the time. I'm like, bro, you didn't recover yet. Like, what are you doing going out and doing all that running? Like,
what was the injury?
I don't remember I forgot the specific injury, but one of the common running injuries.
Yeah, one of the things that's really common in MMA is someone getting knocked out and then getting knocked out again because they come back too quickly. It happened recently in a big fight, and it's just there's a thing that happens with these guys where they just want to get back in there and get a win, and a lot of times they're like, "I'll be ready. I won't get hit again. I know what I did wrong. I'll be better this time," but they're more vulnerable now. Like, they can get knocked out. Is this just neurological damage? Is this just a function of the concussion, or do you think it's a function of the concussion, the recovery from it, and the diminishing capacity of the body because it had to recover from that traumatic injury?
I think it's all of those.
Too, right? Yeah. So it's not just the fact that you got knocked out and your brain is more vulnerable now. It's like, no, your body's more vulnerable. You're probably not as strong as you were. You're probably not recovering as quickly.
Yeah. I mean, the brain it's a small part of the body, but it's massively outsized in terms of the energy that it consumes. And so think about if you're actually healing the ability for it to, like, if it's just sucking even more disproportionate energy from the body, and just think about how much the rest of the body works to support the brain. Like, the liver is working all day long to make the brain get enough energy. So yeah, there's no way that healing from a brain injury is not taking a toll systemically. That's impossible. But
to accelerate or enhance that, creatine, you think would be a very good option?
Creatine is one of the ones that's been demonstrated to do that, and it's been studied 20 grams a day. I don't think anyone really knows, like, do you need 20? Is 30 better? Could it have been done with 5? But most of the brain research is being done with doses around 20 grams. And the thought is that the muscles are going to take first dibs, and you need to have a high dose to get it to the brain. There's a lot we don't know about that, but, as a default, like, if I was healing from a traumatic brain injury, I would take the creatine. And then I think if you have something that's this serious, you do want to, like, know what your limiting bottlenecks are. So I think actually doing mitochondrial testing that's like one of the applications would be like, oh, now it's really important that I have a 6-month window where I need to maximize everything I can. And so, testing to understand your unique needs, I think would be a way to supercharge that process when it's needed. And I think that there are, and so to take this back to like what can people do in general, I think methylene blue you mentioned is one of those ones where, like, I personally wouldn't even take it without testing showing that I need it. But CoQ10 is an interesting one because CoQ10 is actually made in the body and it is found in food. And so methylene blue was, a lot of people emphasize that it was the first, it was the first drug. So it's like the first, example of pharma, basically. But before that, it was actually patented as something that would turn your clothes blue but wouldn't come out in the wash. That was the patent on methylene blue. Whereas CoQ10, you eat food, it's there. Your body makes it itself. And
what kind of food is it in?
Heart is the best. And so I was saying before, you should be eating nose to tail. Like, if you're going to eat meat, you should be eating heart. I personally, most of my meat is actually a blend of, it's like 60% ground beef, and the rest of it is a blend of liver, heart, kidney. And there are some other, mine is just liver, heart, and kidney. There are some other companies that I've seen recently come out with ones that include spleen and adrenals and very small percentages. But I do strongly believe in a food first, pharma last approach. And that doesn't mean like I'm against pharma, but it means that even with supplements, like if you can meet a need with food, you should meet the need with food. You should use supplements in a strategic sense, not as a replacement for a bad diet. And those supplements should, what you would do next is say like, okay, I'm really having trouble getting enough whatever nutrient. Maybe I'll supplement to compensate for that. But I think you should go on down the line with, other things that are like supplements of things that occur naturally in your body that are of course safe to be in your body because they're always going to be there. Maybe you can supplement with that to help break a vicious cycle of aging or to stimulate a virtuous cycle of healing that, I would, once you're getting all your nutrients and you're trying to do that from food, I think that you could start playing around with that stuff. But even then, so CoQ10 is a great example. I would try eating more heart before I would try supplementing with 400 milligrams a day of CoQ10, for example.
Can I ask you this?
Yeah.
Does it matter if it's chicken heart, beef heart? Is there a superior?
I don't think we have enough data to say that. So CoQ10 is one of those things where the nutritional databases are not that. I mean, you're not even going to find it in USDA database, but there's published literature. But I have not seen all the different hearts compared.
So how do we know that CoQ10 is in heart?
Well, wherever it's been measured in heart, it's there. So like the representative examples of heart that were used were like an order of magnitude higher in CoQ10 than anything else.
And is
but we haven't.
upon,
Yeah.
I'm sorry.
We just haven't seen all of the different hearts compared to each other.
Is it dependent upon how it's cooked, like whether it's rare, well done?
I think you lose some during cooking, but I forget how much, and I don't think it's all of it. So you're always the more gently you cook your food, the better off you are in every conceivable case. It might not always taste the best,
Except for parasites, of course.
You don't need to make a steak well done to avoid parasites.
Not steak, but pork.
Right. Yeah.
Or other things, especially
Right.
some wild game.
Yeah. Right. So taking that into account, the nutrient value of the food is always going to be highest when the food has been cooked relatively gently. But anyway, so CoQ10 is interesting because it's hard to argue against taking it from the literature because there's dozens of clinical trials. Quite a bit of it is in heart disease. It looks pretty promising in various forms of heart disease. But if you look at that literature, what you see is a dose response where at 1 to 200 milligrams per day of CoQ10, the average person's glucose, insulin, and blood pressure looks better than not taking it. But the average person at 400 milligrams of CoQ10 is actually having worse blood pressure, glucose, and insulin than they were without taking it. And the variability around that is huge. So one person is probably going to be worse at 100 milligrams, whereas another person might get their best at 400 milligrams. But it's like, if you looked at the literature and you would say, where is the sweet spot where the average person is going to be doing really good? It would be 100 to 200 milligrams a day. But I think I've seen a lot of edge cases on either side where some people get miracles and some people get, I wouldn't say catastrophe, but they just get worse off. So a lot of people complain about insomnia. They complain about their heart racing or heart palpitations, various things like that, overstimulation, feeling like the lights are too bright or the sounds are too strong or whatever, just hypersensory awareness. It's not common, but it's all the people with uncommon stuff always ask me about it. So,
right. At higher levels? Or
No, just like at 100 milligrams. Like they're just hypersensitive people out there.
Okay.
Yeah. And
is this rare? Is this like...
I don't know how common it is. So what I can tell you is that across the trials, you see some people reporting GI side effects, which is super common. You don't see a lot of this mentioned, but you never know if they were looking for it. Like a lot of times the side effect list is dependent on what side effects they asked about.
Is this something you take with food or without food?
It would be better to take it with food.
And is the side effects, is it dependent upon when they take it? Like whether it's morning or evening?
I think for some people that have complained about insomnia, they have thought that it was worse when they took it in the evening.
Makes sense, right?
Yeah.
Yeah. So maybe increase function if you took it early, or maybe increase energy levels.
Okay. So I think, let me set the stage for this with just kind of like, I think this really helps explain like what should you actually be thinking about to know that you're healthy. And I think we struggle a lot with like, I think the medicine just thinks that being healthy is just not having any disease. And I think we as kind of the, wellness community or whatever, struggle to come up with a good definition for health. But I think a really good definition of health for me is you should be abundantly supplied with all the energy that you need to fulfill the goals that you're trying to fulfill, and you should be adaptable enough to be able to handle things changing that were out of your control or your own purposeful changing. And I think the North Star for you to see when to know that you are healthy is that your energy to anxiety ratio is very high and your libido is very strong. And so when you start losing, you use energy not only to produce, maintain, repair everything, but you also use it to distribute everything. And so one of the things that you do with like the last 10% of energy you make is help determine where all the energy goes. And so a lot of people think that like if their mitochondrial function is declining, they should feel tired all the time, but that's not necessarily the case. It might be that you're just losing the energy that you need to actually help the mitochondrial chemical energy to help control how you use energy. And so you are wasting it as anxiety, and that's coming out of productivity. So it's like you look at how much energy did I have yesterday and what did I get done? If the answer is, well, I felt wired all day, but I wasted most of it thinking about why my wife insulted me and then worrying about how I was going to pay the bills, and so I didn't actually get any work done, like that's a good sign that you are losing control over where your energy is going. So that's not good. That's not healthy. Healthy is you have abundant energy to put towards productive things. And so you should see from that you feel energized when you need to be alert, that your anxiety levels are very low, that your libido is very high, and you can adapt that on an age-dependent manner, but and that you are able to sleep very deeply. And if all your energy is keeping you up at night and then the next day you're sleep deprived, your biggest problem is you're just not putting the energy to where it's supposed to go. So I think when you're looking at something like that, you could say, well, maybe CoQ10 is just increasing their energy. But to me, that they lost a little bit of energy, and they lost the energy that they needed. Like they lost the top 10% of their energy, and then that made them not be able to control where the next 20% went. And so it spilled over into their heart was racing, or it spilled over into they couldn't fall asleep at night.
Right.
But I've also, I've also seen other edge cases where people get miracles from CoQ10 that you also are not going to find in the literature. So I had this.
What kind of miracles?
I'll give you one example. So in the program that I had a client named Jacqueline, and she lost her period at 28. So you call that amenorrhea, but she described it as I hit menopause way too early. She didn't have her period for 10 years. So we did mitochondrial function testing on her that showed that you have a specific need for a lot of CoQ10. And what was crazy was she had gone to functional medicine practitioners, did homeopathy, all kinds of, she just went to whatever she could find, and nothing ever changed that. But what's crazy is that functional medicine practitioners often give bagfuls of supplements to their patients. And, so she had gotten normal doses of CoQ10 in the past, 200 milligrams. But based on the testing that we did, we said you should probably experiment with 700-800 milligrams.
Whoa.
So, which, by the way, is above where the average person's glucose and insulin gets worse. But 2 weeks into taking the CoQ10, she got her period back.
Wow.
After 10 years.
That's crazy.
After 10 years, yeah,
That's
it's nuts.
crazy.
So I think CoQ10 is methylene blue. I'm a little bit more hardcore. Like you really got to do the testing. Whereas CoQ10, I'm kind of like, you should play around with it. Like you very well may benefit from 100 to 200 milligrams a day. But my food first, pharma last approach says, are you eating heart?
Right.
Did you eat heart today?
Right.
Yeah.
Well, that completely makes sense. And it also completely makes sense that it would be more bioavailable in food. You'd absorb more of it.
I think that's, that could be part of it, but then it's just,
Comes in a natural
it's just also
form.
there's so much other stuff in the food,
Right.
So it's like people get obsessed with whether they should be taking this thing or that thing, but that thing, if you got it from that food, gave you 36 other things.
Right.
And it's just,
And they work together.
and they work together and they can also become imbalanced. So I think a lot of mitochondrial energy metabolism is the bottlenecks that people can have is kind of like jammed up traffic. And a lot of times you can megadose something, and the main problem of megadosing that for anyone would be imbalance with something else. But if you got a blockage in that something else, now you've just got like a train wreck happening in your mitochondria because you're activating one pathway that has to flow through the next one where you had your blockage, and it's like that. So you can go online, for example, and find communities where people are raving about high dose thiamine, and the RDA, the government recommended amount of thiamine to get is around like 1.3 milligrams. There's people out there who are like, oh, everyone should be taking 2,000 milligrams per day. But I saw one case where this happened before I knew the person, but they had fatigue so bad that they couldn't get off the couch. And so she was self-rating her energy at 0. And a practitioner said, well, you should really try this high-dose thiamine. So she went on 1,100 milligrams a day. So not 2,000, but big, right? And a lot of people get miracles out of this, and they are vocal. They make communities on Facebook, and so people get the idea that everyone who tries it is benefiting from it. But her energy did improve a little bit, but she developed a completely new motor dysfunction problem, unsteady gait. It just kept getting worse the whole time she was taking the thiamine. She had an existing problem with dizziness that got a lot worse. And a major issue for her was that she had to clear out the thiamine, but the mitochondrial testing that we did on her basically showed that like it explained it because she had a block in the pathways that would be most sensitive to megadosing that supplement. And so, winding that back and re-nourishing those other pathways helped her. I do think that a lot of people, if they're going to go into the wild, wild west of megadosing random supplements, should do their own testing of glucose, ketones, and lactate at home. A lot of people test their glucose. Not a lot of people test their lactate, but I'm 100% confident that woman, had the practitioner said, try the thiamine and see what it does to your lactate. And if it goes down, it's good. And if it goes up, it's bad. I think she would have stopped it after the first few days, and the new onset motor dysfunction never would have happened. And so maybe she wouldn't have done mitochondrial testing with me until months after that, but it wouldn't have been a big deal because she had this real-time indicator of mitochondrial dysfunction that she tested herself at home that showed her, oh, I'm trying this, out of left field thing. Let's see, am I getting a stress signal out of it, or am I getting the signal that my mitochondria are calming down and are more happy with their function, which is really what lactate is telling you. And, most people who do lactate testing do it in exercise. And what you see in exercise is when your body's under an incredible amount of stress, you see lactate levels go up in the blood. Halfway through a pro basketball game, lactate is through the roof, right? Well, if I take thiamine and the next day it looks like I'm halfway through the basketball game when I wake up, that's a sign that something is out of whack in my body, right? But to go back to like if the perspective was you might need more thiamine, so you should try adding some nutritional yeast to the dishes that you want to impart a cheesy flavor to, which is what nutritional yeast tastes like, because nutritional yeast is really high in thiamine. Then that probably wouldn't have happened because the dose would have been a lot lower. She would have gradually gone into it much more gradually, but also whatever those blockages were would have the other nutrients assisting them, so the thiamine wouldn't be so out of balance. So it's not just that you absorb it better or whatever. It's also just the food, going food first really helps correct for errors that are a problem with your expertise. Warren Buffett once said that a diversified portfolio is great protection against ignorance. He said it doesn't really make sense if you know what you're doing, but if you don't know what you're doing, you really should diversify. And so that's what food does. Food is a diversified portfolio. And if you don't have the expertise to run around taking different things that you don't understand, if you don't understand the biochemical pathway of the thing you're megadosing, you are not a candidate. That's like, buying an ETF and you don't even know what an ETF is. It's like, give that to your financial advisor.
Right.
And so I think that food first, pharma last is the food first part of that is really just a protection against, but I do have the expertise and I still do food first because I know that my expertise in my own body is incomplete. And so, I might know 1,000 times more than the average person about what thiamine does in the body, but thiamine's doing things in my body and I don't know what they are. So I'm not going to assume I know everything just because I have top-notch expertise in the field.
Right. When you're talking about methylene blue and CoQ10 and the benefits on mitochondria, what's the mechanism, and are they similar? Are they interchangeable?
They are not similar and they're not interchangeable. So CoQ10 is, and ask me if you want me to go into even more detail, but if you extract energy from food and then you need to carry that energy through a pathway, CoQ10 is about 2/3 through that pathway. And it's like if you were going down a road and you had to take a shuttle across the river to get to your next destination and then you go get on the next train or something like that. So CoQ10 is just part of the transport pathway as the electrons come through that are taken out of food to ultimately convert to ATP. Methylene blue is, if CoQ10 is like the main ferry, methylene blue is this guy running around waving his hands in the air. Oh, you know what methylene blue is like? It's like those fake taxis at the airport, where like you're trying to go to the taxi line and they come right up to you and they're like, "Excuse me, sir, do you need a taxi?" But it's like the shady taxi. Mm-hmm. So methylene blue is like an army of the shady taxis, and they're like, "Oh, no, don't take the ferry, come over here," right? And so if the ferry is blocked, methylene blue would be great because, if there's no taxis left, you'll take the shady way because you got to get somewhere. So methylene blue it's operating on the outer edges of the main pathway and it's giving you alternatives. But the mitochondrial pathway that you were born with is the one that is best. It's the most efficient one. So like I was saying before, methylene blue is great if you have a blockage there and you need a detour. It makes you worse off if you don't. CoQ10 it's the reason you can overdose on it is because it's like, okay, there's a river and you got to get a ferry going across it. Well, what happens if there's 10 ferries or there's 50 ferries or there's 150 ferries? At some point, they're going to be running into each other and you're just going to clog up that. So at some point, putting more vehicles into any pathway just makes things worse with the traffic that results. And if you have too much traffic, you get accidents. And, train wrecks and car crashes and your mitochondria aren't good for you.
Would CoQ10 have a similar benefit in terms of like red light therapy, increasing mitochondrial function?
I think they could be synergistic. I think they could be synergistic. CoQ10, by the way, it also helps you make more mitochondria, and that's called mitochondrial biogenesis. Exercise also helps you make more mitochondria, and I do think that so you should never take CoQ10 as an excuse to not exercise because exercise is very specifically putting the mitochondria where they belong to meet the adaptation that you are stressing. So that's mitochondrial biogenesis number one. But CoQ10 will help with that. You don't always want mitochondrial biogenesis. I do think like testing is another case where that might be a case where like you could use a high dose CoQ10 to try to stimulate more mitochondria if testing shows that you don't have enough and that's your like limiting bottleneck. But the average person whose CoQ10 levels are just a little lower when where they should be, it really is just acting as that kind of like you open up the biochemistry textbook, you see the place of CoQ10 in the mitochondrial energy production pathways, and it's just doing the basic textbook thing of helping you move those electrons along on the path to convert food to ATP.
One of the things you brought up earlier was seed oils impeding the absorption of certain nutrients. Seed oils are a weird thing because so many people pushed against them and said, "Hey, these are essentially industrial lubricants that have been converted to food oil for profit, and it's not really the best stuff that we should be consuming." And then you have a bunch of online contrarians that say, oh, there's nothing wrong with seed oils. This is all nonsense. There's no data. There's no studies. And I don't understand that thought process. And when you know what they're made with hexane and all the whole fucking disgusting process of making them versus pressing olive oil. Like to me, it just seems so obvious that one of them you should probably avoid. And then when it's connected to all sorts of inflammation and all sorts of various issues and what you were talking about earlier, impeding the absorption of certain nutrients, what do you think is going on? First of all, why are people defending seed oils? And what is the real problem with seed oils in a human diet?
Seed oils make your tissues more vulnerable to damage, and they don't damage your tissues. And so one of the problems that has caused a lot of controversy, and I think the reason there's so much back and forth over this, is that it takes the right type of study to see seed oils making your tissues more vulnerable to damage, because you need enough time for the damage to play out, and you need people who are more vulnerable to the damage. And we've been talking a lot today about how aging is increasing that tissue damage. Like everything is, your repair capacity goes down as you grow older because your mitochondrial energy production is going down. And one of the things you want to look at is, what do seed oils do to you by the time you're 75? And you don't just want to look at what do seed oils do to you when you're 25, because you might not be seeing the capacity for the increased vulnerability of tissue damage. Another thing is the trials have to be long enough, both because it takes time to see the process of tissue damage play out, and also because we know from long trials of seed oils that short trials are useless. And there are a lot of the people who are talking the loudest in defense of seed oils are looking at trials that last 7 weeks long or 12 weeks long, and they're ignoring trials that were done in the 50s, 60s, and 70s that were 5 to 8 years long. And I'm just like, by all means, analyze the shorter trials, but do it in the light of what we know from the longer trials. And the most important of the longer trials was the LA Veterans Administration Hospital study. And this was, the primary paper on it was published in 1969. So it takes us back in history. But there was a period between World War II and 1970s where there was a lot of motivation in the research community to do these grand randomized controlled trials of nutrition. We don't have that anymore. And I think it's because scientists love to in their collective imagination to say that what they're doing is they're just carrying forth a linear path of addressing knowledge gaps left from the previous literature and just making a linear progress in science. But they're really not, because the incentive structure is to publish a large number of papers in high impact journals on a yearly basis as your university reviews get done. And so if you're going to sit, and then there's other incentives too, because you have to get grants with preliminary data. So you have shorter studies that you then say, well, I'm going to do a longer study now, and it keeps the grant cycle going. And then the people who write the grants want to see things getting published out of those papers. So for you to be like, I'm going to do a 12-year randomized controlled trial of seed oils, it's going to be hard to get the people, get all those box checked. Like you might not be publishing a paper for a while. So what the LA Veterans Administration Hospital study showed was that they randomized people to seed oils or traditional fats, and in the first 2 years, you had a little bit of a heart disease benefit, but then it wore off over time. And so the heart disease mortality basically by the end of the trial was just kind of flat. But the cancer was the same for the first 2 years, but then at the 2 to 5 year mark, it started diverging, and you see, oh, it looks like there's something there. The 5 to 7 year mark, it's, traditional fats down here, and this gap starts widening where seed oils are up here. And then by the end of the study, total mortality was kind of flat the whole time, but it just started to diverge at the end of the study to favor seed oils causing more death. And this study was the longest. And it was also the one where the only trial ever done with seed oils where the mean age was 65. So the people were older than in every other trial. And one of the important things about being old is that's what makes you able to get cancer. There are some childhood cancers, but in general, people start getting cancer when they live long enough to not die of heart disease first. So doing the trial in older people for longer is what allowed you to see that the seed oils seem to be able to cause cancer. And what the author's conclusion was that because the total mortality was just starting to diverge at the 8 year mark, and because they had a plausible reason for it, that the cancer was exploding, they said, we have ultimately left the question of whether these oils are toxic unresolved. And the one thing that we need is, instead of the previous goal of the trials being 5 years long, that the trials be done well in excess of 8 years. Okay. So scientists think that they're just like looking at the old literature and they're saying, oh, what was the gap in the knowledge that we need to solve next? Well, I'm telling you, they concluded in 1969 that the gap in the knowledge was we need a trial that's a lot longer than 8 years. And what did we get? 7 to 12 week trials. It's kind of like that, who was it? Peter Thiel or someone had a tweet that was like, they promised us flying cars and all we got was 180 characters or something like that. Whatever that quote is. Mm-hmm. They promised us well in excess of 8 year trials was the next thing we needed to study. And 50, 60 years go by and all we've got is these 7 week trials and 12 week trials. Now we also know why seed oils would take a while to have such negative effects, because it actually takes you 4 years just for your tissues to start looking like the seed oil you're eating. Like if you switch from butter and olive oil today and you go on corn oil, it's going to take 4 years for your tissues to fully look like the corn oil. And then once that happens, you've got secondary effects. So you start getting your vitamin E levels depleted much faster. But it takes a while for the vitamin E levels to go down in order for other effects, other results of that, like the increased vulnerability to the tissues being destroyed. All that stuff is like you're not even starting to see it until 5-6 years go by. And so I think that's the big reason that there's so much controversy, is that for whatever reason, there's some people who just don't want to look at the older trials that were very long, and they're spending all their time looking at these very short-term trials. And is there a motivation behind that, or is it just laziness? I'm not sure.
I think it's attention. I think part of it is attention. Yeah, it's a big part of it. Yeah. Part of it is justifying the contrarian position with these short-term trials, because then you could dunk on people and get attention.
Yeah, that makes a lot of sense. Like everyone has to get attention somehow if they want to make it in this world.
Well, that's the side effect of this influencer culture, and it's one of the things I really appreciate about your work. You are very evidence-based, and I've been paying attention to your stuff for a long time. You're never hyperbolic. It's always very rational. It's very balanced. And I think that is really important, because there's a lot of people that they make these videos or they have social media posts and it's insulting, inflammatory, and they're doing it for attention. and they're doing that, that kind of behavior for attention along with science. They're adding the science into it. But it seems like the science is just a vehicle for them to get attention.
Yeah, well, I mean that's unfortunate because there is health hanging in the.
I know it is unfortunate, but it's also common. It's really common. Yeah. You see it in all sorts of different disciplines. You see it in archaeology. You see it in everything. There's people that want to dunk on their opposition, and that's part of how they're getting attention, is by insulting people. And you see it, but when you see it in nutrition, it's just it's really weird, because it's not necessary. And the people that are getting attention, whether it's Andrew Huberman or yourself, a lot of people that are just doing evidence-based stuff and being really rational about it, and that's how they're getting attention. And other people are seeing them and going, I need to dunk on that guy in order to elevate my social profile. And the seed oil thing is a weird thing to defend. It just on the way that it's manufactured. If you just watch the process and go, do you want to eat that? Do you want that? Or do you want butter? Butter seems way better. It seems way more normal. It seems like your body would accept butter a lot easier than it would accept this fucking insane process where you're dumping a bunch of chemicals into this goop, this nasty shit that you're pushing out of rapeseed oil, and you're calling it canola oil. You know how many people think canola oil is corn oil? Because corn is canola. You think of corn. Oh, corn oil must be good for you. It's vegetable oil.
Well, it is funny that they named it after a Khan.
It's fucking weird. A Khan?
There's an article not by me but by someone else called The Great Khan-ola, and it's about how canola oil is a Khan, but it's they name. But anyway,
that's a good way to put it, because canola oil is a con.
Yeah.
Because many people, I've seen canola oil where they have a fucking image of an ear of corn. Have you ever seen that on the label?
I don't look at canola oil labels, but
this was.
It's been a while since I bought a bottle.
If there's something you can find that shows that. Because I hope I'm not having a false memory, but I'm pretty sure there used to be a canola oil that had like an ear of corn on it. It's rapeseed, and it's a industrial lubricant, and that's what they used to use it for. And it's a byproduct. It's a weird, funky thing that they have to pour a bunch of shit into just to take the smell out of it, just to take the rancid smell out of this weird oil that you're cooking with.
Yeah, you can buy cold pressed seed oils. It's not what most people are eating food with, but I still think that the fundamental problem with it, it's not just the processing. It's also, if you look at ancestral human diets, no one ate fatty acid compositions that looked like that, because the reason that they usually use hexane to extract it is because it's actually difficult to extract using purely mechanical methods. So olives can be pressed into oil.
Right, that is a type of seed oil, right? If you thought
no,
about
olive is a fruit oil.
Or fruit, but avocado, is that a fruit as well? Avocado oil?
Avocado oil is pressed out of the avocado.
Right, and
because avocados the flesh is super high in fat.
Right,
it's like
so it's just the pit inside of it is the seed.
Yeah, I don't think they make oil out of that.
So it's a fruit oil. So whether it's olive oil, the high heat ones are avocado oil. That's one that people like to cook with, right?
Yeah. Well, okay. So
are there any issues with that?
So cooking with an oil, one issue is the smoke point, because the oil is burning at its smoke point. And that probably is more of an indication of flavor than it is of health, but it is generally going to correlate. Like if the oil is burning, you're more likely to have damage to the oils. And consuming oils is bad for you. There's the smoke point, there's the fatty acid composition, and there's the solvents and other chemicals left over from the processing. And I think all of those are an issue. But the fatty acid composition is like seed oils has become the common thing to use as a nickname for it, but but what you're really thinking about is that they're high in polyunsaturated fatty acids, or PUFAs. And those polyunsaturated fatty acids are just like it happens to be most oils that are currently on the market for food consumption that are very high in polyunsaturated fatty acids are what we call seed oils.
Right.
So that's why we call it that way. But the actual fatty acid composition, like if you go back to any oil that was easy for humans to produce before, say, 100 years ago, then you don't see those, you don't see a strong tradition of large consumption of rapeseed oil going back or cottonseed oil or corn oil, because try squeezing a corn kernel. It's not that squeezable. And so when you have these very small, hard things, that's why you wind up getting solvent extraction, but you had to do the solvent extraction because it was not easy otherwise to get oil out of those things. The solvents is a whole nother thing. I was in a lab once where someone had us analyze residual hexane in foods, and they just bought a bunch of grocery store foods, and I was kind of managing the data analysis while someone I worked with was doing the hexane measurements. But let me just say that if it's extracted with hexane, it's got hexane left over. And we saw something that was not hexane. We didn't know what it was, but it was some chemical solvent that was massive in the pump spray oils. And after I saw that, I was like, I'm never using a pump spray oil because they you could put olive oil in like a mechanical spray bottle, and that's fine. But like Pam and those other ones, they're using chemicals to make the spraying work, and there's something that's some chemical solvent that's just like way like massive proportions in it. So after I saw that, I just stopped using those. I won't go near those.
Yeah, I don't go near those anyway.
Yeah.
But what about grapeseed? I know grapeseed is one that people like to cook with because it has a high smoke point.
Yeah, I would put grapeseed oil in the category of a seed oil that I wouldn't consume in high quantities.
And is hexane an issue with that as well?
Not if it's cold pressed. I mean, you can get like organic cold pressed grapeseed oil that is not solvent extracted. It's not RBD. It's not heated.
But you still have to deal with the polyunsaturated fatty acids.
Yeah, I mean, it's very you're paying a lot to get a high quality product, but it's still like, there might be studies out there about some therapeutic benefits of some of the components of the grapeseed oil, but I wouldn't want to make those fats be the major oil in my diet, because I think you're just overload. Like it's high in antioxidants, and so you're going to get benefit. There's going to be beneficial things in it, but I don't think that those fats are what you want to be your main fatty acid consumption.
What about if you were searing a steak in grapeseed oil? Would that be an issue?
I mean, the less of the oil that's there, the less of an issue it is. If you're just coating the pan with it and it's convenient because it doesn't have a high smoke point, I wouldn't worry too much about it.
And
but I wouldn't be
healthy fats from the
I wouldn't
meat.
want to be consuming like a tablespoon or upwards of grapeseed oil a day.
So I think we would agree that the issue with saturated saturated fats and just in the zeitgeist, saturated fats we have demonized since whatever that study was where the sugar company bribed those scientists. Was it the 50s, the 60s, wherever it was, where they spent.
It started back then. The kind of the crowning turning point was 1984 when Time magazine had a picture of a frowning face made out of eggs and bacon, and the cover said, "Hold the eggs in butter. Cholesterol has been proved deadly, and our diets will never be the same." And
we got to pull that photo up. That's so crazy. They really did that?
Yeah, they actually they reversed it a few years ago, where they took the same image, but they made it a smiley face, and they were like, "Now we know eggs are good for you."
Oh, God. But meanwhile, how many lives did you ruin with your shitty advice? It's so stunning.
Yeah. You can see the two right there.
Yeah.
You can see both side by side.
Crazy.
Yeah,
and
so
then
the one
cholesterol,
on the
the
one
good
on the right,
news is the upper left-hand corner.
Yeah, the upper left-hand corner is the new one. And the one on the right is the 1984 one.
Scientists labeled fat the enemy. They were wrong. Yeah, you didn't print the whole thing. They got fucking bribed. And not a lot of money. That's what's really crazy. It ruined society, ruined diets for what, $50,000? So for $50,000, people started eating margarine and eating seed oil and not eating butter and not consuming cholesterol, which is, the building blocks for hormones. It's such an important aspect of the human diet. And when you tell people that, like I tell people I eat mostly meat, they go, "What about your cholesterol?" I just take a I don't know what to tell you. Go read. I just can't. I can't sit there and tell you that higher LDL cholesterol is actually associated with longer lifespans. It's like there's a lot to this whole cholesterol thing, and I think it's kind of been fucked around with by the mainstream media reporting on these sort of ancient narratives. These narratives that, again, not ancient, but these narratives that were set up in the 50s and 60s, whenever it was, and the 80s, the Time magazine thing, that people just repeat. They don't look into it. They just repeat it over and over again, and they're really worried. Like, I'm trying to eat less red meat. Like, why? Why are you trying to eat less meat? Well, it's, cholesterol. Like, oh, boy.
Yeah, I do think that you don't want to see your blood cholesterol going crazy high, because that can be a sign that you're not using it well, right? Like if your cholesterol is turning over and it's being used to make bile acids to support your digestion, it's being used to make adrenal hormones and sex hormones, it's being used to make testosterone, it's being used to make brain synapses to support your memory. Like, all those things that cholesterol does are incredibly important. But I think a lot of people, their cholesterol going up can be a sign that they're not using it properly. And so I think that's why you do see, it is true that if you take people at a certain age, you can see inverse correlations between cholesterol levels and mortality. But if you take people who are younger and you look at who's going to get heart attacks later, you do see that higher cholesterol when you're younger prospectively predicts a higher risk of heart disease later. And I don't think that's because cholesterol causes heart disease, but I think it's because it's a reflection of your overall metabolism being more slow in terms of actually using up the cholesterol.
Makes sense.
And that also, but it's interesting though that if you look at the mechanisms of how does cholesterol cause atherosclerosis, the cholesterol is inside a lipoprotein, which is like a spherical container for the cholesterol. It's got a bunch of fat-soluble vitamins and other things in it. But the outside is fatty acids, specifically in the form called phospholipids. But what happens that drives the atherosclerotic plaque is that the fats you get from seed oils that are on the outside of it get damaged. And when they get damaged, the immune system recognizes it as a toxin that could hurt the blood vessel. And so the immune system gobbles it up and sequesters it. And that sequestering is like a quarantine. And that's what the plaque develops from. And so that's why, like, even though you see prospectively that if your cholesterol is higher, that predicts that you're more likely to get heart disease later, in the randomized controlled trials, you saw something quite different when they used seed oils to lower the cholesterol. So the Minnesota Coronary Survey was another, I mentioned the LA Veterans Administration Hospital study. These were the two double-blind randomized controlled trials that were done of seed oils. The Minnesota Coronary Survey was very big. It was the only one that included women, and it wasn't as long, but it was way larger. And back when they published the results, it looked like there was an 8% increase in the risk of heart disease with the seed oils, but they mentioned that they measured actual atherosclerosis and they didn't report it. So decades later, like I think it was about 10 years ago, researchers noticed this and they said, well, the guys that did this study are dead, but I wonder if the atherosclerosis results are around. So they did some digging, and it turned out that in the basement of the house that the lead investigator lived in, who had died a long time ago, there were boxes of data that had not been published from that study, and it included all the atherosclerosis measurements. And what they found was that the seed oil group had double the atherosclerosis. Not only that, but every 35 milligram per deciliter drop in cholesterol was associated with something like 30% more heart disease. And so the original results didn't look good for seed oils. They looked bad, but they didn't look that bad. And they weren't statistically significant. But it was because there was a lot of, people were coming in and out of the trial. It kind of weakened the results. But this, the atherosclerosis results and the correlations that were buried in those boxes show that when you look at the data from that angle, like the seed oils look a lot worse. And I think what you're seeing there, this is one of the reasons why there's so much material to work with to make controversy out of this, is that you see that people with higher cholesterol when they're younger are more likely to go on to have a heart attack. But when you use seed oils, which lower the cholesterol in the blood, but increase the amount of these easily damaged fatty acids that carry the cholesterol, and they get damaged and they drive the atherosclerotic plaque, that's why you see this divergence. Like, that correlation exists there, but not everything that you do with your diet to change it to try to make the correlation work in your favor does you good.
Right.
Yeah.
Right. I'd read that. I'd read something about that, and also something about there's a profound difference between someone who consumes their cholesterol, like say if you're on just a seed oil free, just vegetables and meat with healthy fats, like those kind of carbohydrates or those kinds of proteins and fats without complex carbohydrates, without consumption of a lot of grains, without that. There's a difference in the results that they were having in terms of the impact of cholesterol.
In general, you are going to have higher cholesterol if you're eating less fiber.
Right. And is it in it all dependent upon the activity level of the person? Like you're talking about using the cholesterol.
Well, I think this is a great tie back to the things we were talking about before, because the clearance of cholesterol from your blood is driven by the mitochondrial energy production that gives your brain the signal that you are in a state of abundance and should put that cholesterol toward good things. And you have a bunch of hormones that communicate that. Leptin, insulin, thyroid hormone are all involved. But what is ultimately driving this is your brain, especially in the hypothalamus, is taking information in that says, are you getting enough food for me to consider this a state of abundance, where I ramp up your digestion, I ramp up your libido, I ramp up all these things. And we tend in nutrition science to think that this is about calories or it's about carbs, and it is about those things. But if you are half as good at mitochondrial conversion of food to ATP as the next guy over, is your hypothalamus gonna give you full credit for the food you ate in terms of calculating your state of abundance? It's not. It's gonna dock you by half. And this is because the hypothalamus takes all these signals and then it looks at inside the hypothalamic cells, it looks at, okay, how well do I convert those food molecules into ATP using my mitochondria? And if it's 50% dropped, it's going to dock you in your state of abundance. And it's going to say, actually you ate all the food, but you didn't get all the energy. And so we're just going to let things stagnate, and the cholesterol is going to go up in the blood. Your sex hormone is going to go down. And, you can look at that and say, well, there's an age, you're going through andropause, there's an age-dependent decline in testosterone and adrenal hormones and stuff like that. And then you can do hormone supplementation therapy. But what you're not actually fixing, but that can also be kind of a negative feedback loop. Like if you're supplementing everything that your body would turn cholesterol into, that also is going to slow cholesterol turnover, because your body's like, oh, I don't need to turn that into testosterone if I'm supplementing with it. So I think that what we're missing in the whole discussion is thinking about how do we ramp up mitochondrial energy production? How do we prevent it from declining and aging so that the brain can rightly perceive that I am in a state of abundance and it is rational to ramp up this metabolic rate. I think it's when you have a marker like this, it's not like every single case of high cholesterol represents a failure to convert it into anything good. Some people just produce more cholesterol or they absorb more cholesterol. And I don't think those are all equal in terms of their heart disease risk or their health implications. But sluggish like high cholesterol is in general a sign of sluggish metabolism under the average set of circumstances. And a really interesting thread that got left behind in 1976 is Broda Barnes wrote this book called Solved the Riddle of Heart Attacks in 1976. And his perspective was all about thyroid hormone. And he argued that people who died of infectious diseases were hypothyroid. We allowed them to live longer. Now all the hypothyroid people are getting heart disease. The reason he thought that is because thyroid hormone communicates to your whole body that you are in a state of abundance. And so if your brain thinks that you're not, and you add thyroid hormone in, now your whole body is receiving the false signal that you are in a state of abundance. And you feel better and many things improve, and you can argue about whether that's good or bad, but you're intervening at the point of the communication instead of at the point of actually creating the abundance. But thyroid hormone does signal, take up cholesterol from the cell, move it along, do things with it. And so no matter whether you're hypothyroid or not, people were up until the 1970s, they were lowering cholesterol and they were lowering heart disease risk by just putting everyone who had high cholesterol on thyroid hormone. And the reason they stopped doing it is because some practitioners got overzealous and they killed a few people because they overdosed them. But Broda Barnes argued that we don't have to be overzealous and overdose them. We could just be rationally dosing thyroid hormone. My perspective is different from Broda Barnes. I take what he said, and I think there's a lot of value to it, but I say, like, why is thyroid communicating the state of abundance? It's because your mitochondria are doing a great job converting your food to ATP. Now, you don't have to have a mitochondrial dysfunction to have low thyroid hormone because you're not in a state of abundance. You can just not eat any food. So, if you look at the metabolic consequences of starvation, you just don't eat any food. Your thyroid hormone will go in the gutter. So there are people out there who just aren't eating enough. Like, that is a thing. But it's also just natural in the process of aging that we're all getting progressively dysfunctional mitochondria, and that we can intervene at any point to have at least 75% of control over that. And so we want to step up the game and, work. So if there's two things that people take away from me today, I would want it to be always think about your mitochondria first, and when you're thinking about them, always go with a food first, pharma last approach. So naturally create a state of abundance in the best way that you can, and then move on to other things after you've done that. That way, if you're going to intervene with testosterone replacement or thyroid hormone or statins or whatever else, statins are mitochondrial toxins, so they're kind of counterproductive from a mitochondrial energy production standpoint. And on that note, so statins, the debates of statin-associated myopathy are the rates of them are debated. The rates at which statins cause diabetes is debated, but it's there. And it's because statins actually inhibit your CoQ10 synthesis, but they also inhibit other things in the mitochondrial energy production engines that you can't take a supplement for. So there's just no way around that statins will decrease your mitochondrial function. So I think by not thinking about mitochondria first, it's like instead you take these people with mediocre mitochondrial function, their LDL in their blood would get taken into their cells. You would do valuable things with it if the state of abundance was present, because not only does all the signaling say do something with the cholesterol, but the way you actually get cholesterol into the cell is to burn through a bunch of ATP with motor proteins that actually move it from outside the cell to inside the cell in order to facilitate that turnover. So we've got a situation where we know that everyone could improve their mitochondrial function, but instead of doing that and then saying, okay, do we really need a statin? We just say, oh, go straight for the statin.
And now you're hurting the mitochondrial function even more. And you're saying, well, it's the ROI is good enough because I'm lowering their cholesterol and they won't get heart disease. And yeah, their mitochondria aren't doing as great, but that's okay because we lowered the cholesterol. I think that's totally backwards. You should always be trying to optimize mitochondrial function first. You should always be doing that with natural foods before you try anything else. And then move on. Like just set the foundation. Set a good foundation and then build your house on top of it however you want. I'm not saying never use any pharmaceuticals. I'm just saying, if you're gonna build your house out of pharmaceuticals, do it on a good foundation.
Right. Make an educated decision. Yeah. What can be done to increase thyroid function?
The first thing is you actually want enough food and you want good mitochondrial conversion of the food to ATP, but there's other things that could be important to having good thyroid function as well, like if you just look at what is thyroid hormone. So thyroid hormone is made from the amino acid tyrosine, which you get from the protein in the food that you eat, and then you add iodine to it. So if you don't have enough protein, you're not going to have good thyroid function. If you don't have enough iodine, you're not going to have good thyroid function. So those are the step one basics of the 101 of the nutrition that I need to have good thyroid hormone.
And is iodine from supplementation or from food?
You can supplement with it, but I always believe in food first.
And what's rich in iodine?
There are many things that can be rich in iodine, but it's highly dependent on the soil. So a potato, for example, from one part of the United States could be 100 times richer than a potato from another part of the country. So that's a problem. Seafood is reliably high in iodine because the rainfall just facilitates the minerals just falling into the ocean. So it's, a lot of the places that are low in iodine, it's because the pattern of evaporation causes the iodine to evaporate into the clouds. But then like the cloud pattern goes around some mountain and it never drops back down on you. And so you get these areas of the country where they're just on the wrong side of the mountain and they just get, progressive decline in the iodine. So I do think that it's good for people to eat just some seafood because like if you eat 1 or 2 pieces of fish per week, for example, or you eat a little bit of seaweed every day, that's going to cover your bases. Whereas like if your food comes from one area, you might be able to get enough iodine just eating whatever you want. And in another area, you won't. I personally add in a 1/4 teaspoon of kelp powder to my food prepped meals per day. And so it's always in there. It's got a little bit of flavor, but I just mix it into everything so you don't even taste it. I fortify my own, I fortify my food myself instead of letting the government do it. But, so that's one way to do that. And then there are some things that increase your iodine requirement. So women with big breasts, for example, can need much more iodine because iodine, the breasts are a sink for iodine. Part of that is just the nature of the tissue, and part of it is very logical because if you do have a baby, you are going to start feeding the baby the iodine, and so that might be part of why that's prepped. But there's some evidence that a lot of breast problems are solved by extra iodine. So fibrocystic breast disease, for example, there's some support for getting 10, 15 times the normal amount, or even 50 times the normal amount of iodine. And I think that's because some women with very large breasts 98% of it goes there. And then there are also like the more toxic your living environment is, the more iodine you're going to need because there's a lot of bromine that's in synthetic materials for couches. It's flame retardants. So all kinds of paint and materials that are used in household living can be a source of environmental bromine. And then fluoride. If you drink fluoridated water and you brush your teeth with fluoridated toothpaste, it's going to increase your need for iodine as well. Oy. So there's a bunch of reasons that people might want to. Well, I'll say this. I think it's crazy that every time I've seen a woman who's on thyroid hormone and I've had them get iodine data, their iodine is low and they've never gotten it tested before. And I just, medicine has these myths about nutrition that like we solved all the nutritional deficiencies 100 years ago, so we don't need to think about it. But they did these dumbass things that nullified that. So, for example, the reason that we didn't have iodine deficiency anymore is because they fortified salt with it. They said everyone eats salt, so let's just put the iodine in the salt. And so everyone had fortified salt. But then what did they do? They came along and they said, don't eat the salts. It's going to give you a heart attack. And so what they didn't realize was when they told people to not eat the salt, now they're not getting their iodine. And now, so there's some places where there's like, I talked to one cardiologist who works out in the Midwest. And he says, I see people walking in with you can see the lump in their throat now. And they have a goiter, which is just like a goiter is a very hungry thyroid gland where it's like, I don't have any iodine. Where's the iodine? It just starts growing to try to find it. And you wind up with, you can feel a lump in your throat, not see anything. But if it gets really, really bad, you can see a bump in the neck. And if it gets insanely bad, you can have like a grapefruit hanging from the neck. That doesn't happen anymore. But this cardiologist told me, like, I actually see people with goiter now, but no one's looking for it because they don't think people get goiter anymore. And so most of them just walk around with a lump in their neck until they find me, he said.
That's wild.
Yeah.
The no salt in the diet is so wild.
Yeah.
That one is so crazy.
And then there are other things too, like the supplement that you're taking has glutathione in it. Well, selenium is a mineral that helps you use glutathione to protect your thyroid gland from damage. And there are a number of trials that show that selenium lowers the autoimmune antibodies that occur in Hashimoto's thyroiditis, which is a type of autoimmune thyroid problem. And the reason it does that is because it's helping glutathione protect the thyroid from damage, because producing thyroid is a very messy process. But that also, if you look at what that would imply, it would also imply that all the other antioxidant nutrients are very important in the thyroid as well, because vitamin C and zinc and copper, manganese, and a whole suite of iron even. Too much iron is bad for you, but you need iron to protect yourself from oxidative stress. So all of these things are helping prevent tissue damage in the thyroid gland, which helps prevent the immune system from going haywire, trying to deal with that damage. And so all of those things are important for thyroid hormone.
One more thing I wanted to talk to you about is you brought up arterial, I don't know how to say that word right, arterial sclerosis. What is the supplement Nattokinase?
Yeah, nattokinase is an enzyme that helps break down blood clots. And atherosclerosis is, what it really is the immune system quarantining damaged particles. Those particles are damaged because you loaded them with seed oils, and then your mitochondrial function declined and you lost your defense against the damage. And then you got progressively more seed oil damage, and the immune system's trying to protect the blood vessel from it. That's what the plaque is, but that plaque is highly inflammatory. And
this is a crazy statement. So plaque that people have always considered to be from, most people will tell you it's from cholesterol. Yeah. If you ask the average person, you believe it's really from seed oils.
I'm not alone in this. So No,
I don't think you are.
If you go back to 1984 when we saw that Time magazine picture, the other thing that was going on politically and scientifically in 1984 was the NIH consensus conference that said that they had proven, Time magazine cover was a reaction to the NIH consensus conference where they said, we as the scientific community now certify that we are in consensus that cholesterol is the cause of heart disease. And that's why Time magazine ran with that cover.
Was Fauci running the NIH back then?
Fauci...
Because that's when did the AIDS crisis start?
So Fauci was not running this, but that was, I think, possibly also the year that Fauci took over at NIAID.
Oh, okay.
Yeah. It's a sidebar, but there's a very interesting study that looked at the average age of principal investigators of studies. Principal investigator means like the guy who ran the lab. And so since 1984, the average age of an NIH-funded principal investigator has gone up by 1 year per year. And so that looks like the one group took over the money in 1984, and then they've just been giving themselves grants ever since, and now they're really old. That's what that looks like. But anyway, so yes, I believe you can fact check me on this, but I believe Fauci took over NIAID, where he became very in control of a lot of NIH money in that same year. So it's really weird the way these years work out. Like 1913, you got Federal Reserve, you got World War I, you've got all these changes to the structure of the government. Like they picked this year out of history, and there's always these big, massive big things all happening in different areas. But anyway, so there was something in the air in 1984. Maybe it was self-fulfilling prophecy from Orwell. Yeah. But anyway,
so
the chair of the NIH Consensus Conference in 1984 was Daniel Steinberg. Daniel Steinberg passed away a few years ago, but he was there were three big names that came out of that conference, and Steinberg was one of them, and the others were Brown and Goldstein, who won the Nobel Prize in 1985, the next year, for, you can see how they hooked up their Nobel Prize. So 1985, they got the Nobel Prize for discovering the LDL receptor, which is the thing that brings cholesterol from your blood into your cells. And all the drugs that work on this are targeting that receptor. So that became the springboard for all the drugs that people are on for cardiovascular disease now. So this is kind of funny that the Nobel Prize was probably in the fix in 1984.
Yeah.
That was the other thing they were working on. But because there's no way that would have happened if the 1984 Consensus Conference didn't happen. But the point I want to make is that Daniel Steinberg agrees with me. I didn't come up with this idea myself. I mean, he's dead now. But, for decades, he was one of the people who believed that because it was his lab that discovered that the PUFAs, which are seed oil fats, have to become damaged on the outer membrane of the LDL particle for it to get taken up by the immune system. That was his discovery. And he's the guy that chaired the conference that led to the Time magazine cover. So I'm not pulling this out of my ass. I'm pulling this out of my having read Daniel Steinberg's papers. And so this is how olive oil became the darling of the Mediterranean diet, which is, so the Mediterranean diet is kind of funny because it's not that it's very loosely based on what they eat in the Mediterranean. And it's really just kind of like a branding thing where they said like, okay, well, this diet is good enough for us to say, eat this, 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 and this, and we're going to call it Mediterranean. But anyway, so what happened was after the LA Veterans Administration Hospital study showed in 1960, well, actually they published it a few years later. So somewhere in the early 70s, it's kind of looking like seed oils cause cancer. And so they're looking at that and they're like, well, maybe corn oil is not the best. And they're like, well, we already told people to eat the corn oil because they can't eat the saturated fat. So we can't tell them to go back to the butter. So what are we going to tell them to eat? And they were like, well, olive oil is a nice balance. It's kind of in between the two. It's not saturated fat, but it's probably not going to cause cancer like we're worried about this. And so olive oil is kind of born out of that. And Steinberg's perspective on promoting olive oil as being good for heart disease was, the Steinberg is saying, I'm worried that the real problem with these lipoproteins in the blood causing the plaque is actually the seed oils that we're telling people to eat. And so, yeah, we can use cholesterol as a marker for that, but I don't know that I want to be telling people to eat corn oil. So what am I going to tell them to eat? Because I'm going to have egg on my face, pun intended, if I tell them to go back to eating eggs and butter. So olive oil is this happy middle ground where maybe we can consume olive oil to our heart's content, and it's not going to create the tissue damage that drives the plaque, but it's also not going to ramp up the cholesterol, and so we can just navigate the middle that way. And the reason that no one appreciates this is because medicine thinks in binaries. So I have this saying, all medical diagnoses are false, but some are useful. And I take this from a saying in statistics, which is all models are false, but some are useful. And what that is an appreciation that once you impose a model on the data, you're now biasing it towards the way you think about it. And, so it's like it's a reality distortion filter to make the data more usable. So if I can use the model to try to predict something and I see it's true, I might leave details behind, but I'm focusing on the things that help me make those decisions. So a medical diagnosis is a hypothesis that the patient will respond to the treatment that they're given. And you test that hypothesis by giving the patient that treatment, and then you see if they get better. And if they don't get better, then you take them off the treatment. That's why, some things people just stay on the drug they're put on. But look at how they treat depression or epilepsy. Epilepsy, they just put them on one benzo, it doesn't work. They put them on the next one. They keep rotating until they find one that stops the seizures. Depression, they put people on one antidepressant. Oh, it didn't work. We'll put them on the next one. They just rotate through it because they're just looking at it like they have a model that predicts their hypothesis that they'll respond. They didn't, so they switched them onto the next approach. So because medicine cares about triaging decisions about what to do for treatment, they say, I only need a model that helps me do that, and I can ignore all the other details. But what happens is you leave these historical threads behind, like the fact that the chair of the conference that proved to put in your magazine that everyone had to change their diet because of the concept that they said was proven, that is now the basis for the drugs that I'm going to prescribe you. The fact that he had these, that he also showed that it was seed oils in the membrane of the LDL particle that drive the plaque doesn't matter because that doesn't change whether I'm going to give you a statin. And so if it doesn't change how I'm going to treat you, it doesn't matter, which means that I could ignore it if someone asks me what you should eat. But the problem was when they did the randomized controlled trials with the seed oils, they were like, oh, it doubled the atherosclerotic plaque. What do we do? Put it in the box in the basement.
Wow.
And so there's all this like, well, yes, those details are true, but Masterjohn, get out of my hair. I can't handle the truth,
Right. And so how does nattokinase?
Oh, yeah, right.
Because I brought you way off track.
Yeah,
sorry.
I
did it.
I did it. Okay, so when you get a heart attack or a stroke from atherosclerosis, it is not because in like 98% of cases, it is not because the plaque occluded the blood vessel and stopped the blood flow. In fact, usually when a plaque develops, it develops backwards. Like it just so let's say this is your blood vessel, the plaque's going to bulge out this way instead of this way because your body tries not to narrow the blood vessel because you do need the blood flow, right? So it's almost never the case that the plaque is just squeezing the blood vessel shut. What happens is the inflammatory process inside the plaque, which is especially driven by the seed oils oxidizing in there and going rancid. That's not the only factor, but it's one of them. That process degrades the collagen that covers the plaque, and it makes micro tears. And the micro tears in the collagen get healed by scar tissue that gets laid on top of it. And so when you get narrowing into the blood vessel, it's because you're building up scar tissue on top of, like it keeps breaking and you keep building scar tissue on it. But if it breaks and you get a blood clot that is big enough in the acute moment to block the whole artery, that's what usually causes most heart attacks. Nattokinase is an enzyme derived from natto, which is a Japanese fermented soybean paste that is also incidentally very high in vitamin K2, which helps you protect against calcium deposits that weaken the plaque and make it more likely to rupture. So actually just eating natto would be better. This is why food first works, right?
Right.
If you had K2 and nattokinase, you'd be even better off. But the nattokinase helps break apart blood clots. So if in some people you might just have a predisposition because you've got systemic inflammation where like you just clot more easily, or you might have someone who's got a genetic defect in the ability to degrade clots, and so their baseline clotting is higher than normal. If that's the case, then they're even more likely to get a heart attack or a stroke when the plaque ruptures because their baseline predisposition to clot is higher. And then on top of that, if you've got someone with really bad atherosclerosis, they might be clotting all the time. Like every day might be a new day where they could have a heart attack. And so in both of those cases, nattokinase is going to degrade the clots as soon as they occur, and it's going to lower the total clotting. And the downside risk of that is, maybe you bleed too easily if you get cut. But the upside potential of that is if you're one of the people who are a candidate for any one of these days now, you're going to get a heart attack or a stroke. Having taken 2,000 IU of nattokinase that day may have prevented you from getting a heart attack or a stroke because the clot formed and you degraded it more quickly.
Fascinating. Listen, there's a lot to take in, but let's do this again.
Yeah, for
please. Sure. And tell everybody where they can find you and where you are on social media and your website and all that.
I write a newsletter at chrismasterjohn, phd.substack.com, and you can look into my mitochondrial testing at mito.me.
All right. Thank you very much. This was really fun.
Thank you, man.
I really appreciate it. I'm glad we did it. All right. Bye, everybody.